Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody let me know in the chat box if I am clearly visible and audible to you or not so that we can start with the questions of BITSAT. Everybody, yes, everybody in the chat box, shall I start or not? Right, am I clearly visible and audible to you? Yes ma'am, hi ma'am, hello. Kavi, Hema, Sai, yes, Adya, hello. So let us start with the questions of organic chemistry, then we will do questions of inorganic, then we will do questions of physical chemistry. Okay, one by one we are going to do that, right? Okay, now starting with the organic chemistry questions. Okay, starting with the organic chemistry questions. As you can see here, first question on your screen is, in which of the following reaction tertiary amine is obtained? Right, if you see this here, right, this will give you nitrobenzene, it is, so it will give you aniline, so that is definitely primary amine. If you see this here, aniline is this thing. In aniline, if you add CH3I, so it is going to replace one hydrogen with CH3, and if you add CH3I two times, in that case two hydrogens will be replaced by CH3. That means in first you will have the formation, this is 3 degree, this is 2 degree. So in first you will have the formation of 3 degree amine, that is A is the correct answer here. Right, A is the correct answer. Okay, next question is carbylamine forms. Now next question is carbylamine forms from aliphatic aromatic primary amine via which of the following intermediate, right? So if you talk about carbylamine, right, so we know that from primary RNC it is formed, this is amine, right, it is formed as RNC, right? And here we know that what we use, CHCl3 and KOH are the reagents, that is carbylamine test, and it give rise to CCl2, that is the carbene that is formed here, that is dichlorocarbene. So that means which thing is formed here? Dichlorocarbene. So answer will be carbene, that is B is going to be the correct answer where carbene is formed here. Right? Okay, yes. Next question is, which amount of, next is, what amount of bromine will be required to convert 6 gram of phenol into 2,4,6 tribromophenol? Right, so it's a mixture of organic and mole concept here, right? If you see, this is phenol, right, this is phenol, right, this is phenol, this is phenol, right? When you add Br2 here, you need to have tribromophenol. So for that, you will have 2,4,6 it is. So it is 1 and 2 and this is third Br. And for this, what we need to have? We need to have 3 of Br2. Because one Br2 will give you one electrophile, that is Br positive. So 3 Br2 will give you 3 Br positive. Okay. So that means this reaction, if we say what amount of bromine will be required for 6 gram of phenol. See, we know that number of moles of phenols, if you see number of moles of phenols, firstly let us see 6 gram. And what is the mass of the phenol? What is mass of phenol? This is C6H6O, right? That is 12 into 6 plus 6, right, plus 12. That is going to be the answer. So it is going to be, what I think, it is going to be 94. Okay, so directly I'm writing it here, 94, right? So it will be number of moles of phenol is going to be 6 by 94. So number of moles of bromine is going to be what? If this is 1, so this is going to be multiplied by 3. So it is going to be 6 by 94 multiplied by 3. Okay, what is the mass of phenol? What is the mass of phenol? Sorry, mass of Br2, that is number of moles of Br2, that is given to be this. multiplied by the molar mass of Br2. Just one Br2, what is the molar mass? So multiply it by the molar mass of Br2, that is 160, right? Just multiply this, you will get your answer. This multiply by this, you get 30.63, right? And that will be your final answer. Okay. So multiplied by 160, that is going to be the final answer. The amount of Br2 that is required in this reaction, right? So that after solving is coming out to be A as the correct answer. You can solve it yourself as well, right? Okay. Yes. So this is a mixture of organic and physical simple mole concept we have applied here. So these kind of questions are very, very important for BITSAT exam. Okay. Now, next, let us see that the product X and Y in the following reaction sequence are what? So, X is this thing, Y is this thing. So, if you see this here, you have phenol and this is alkene. This with AlCl3 is going to form a carbocation, that is CH3, CH3 positive. That is going to attack anywhere here, and X is going to be cumene, right? That is CH3 and CH3, that is going to be X. And after adding O2 here, peroxide bond will be formed, right? COOH, this is COOH, and this is CH3, and this is CH3, right? So that is going to be the answer here, right? That is Y, this is Y. I'll just write it here. This is Y, and this is X, okay? And this is X, right? That is cumene process. Okay, now let us see the options where you have these two options. First is isopropyl benzene. Second is, okay, Y. They are asking you X and Z. Okay, Z is what? After that, you will have phenol and acetone, right? So answer will be this isopropyl benzene and acetone. That is A will turn out to be the correct answer here, right? X is cumene, Y is not phenol, Y is bitter, not phenol. Y is cumene intermediate, okay? Y is cumene intermediate, right? Instead of that CH, you have COOH, that is Y. And here Z is acetone. In the end, with phenol, you have one more byproduct, that is acetone, okay? Next question, let us see that. Next question, let us see that. Next is, in the following sequence of reactions, you have, this is the sequence of reaction that you have. CH3Br, KCN is added. Then with that you do hydrolysis. Then with that you do LiAlH4. See, one you have added KCN here, so that will be CH3CN, right? Because C will be free here, so it will be CN. After doing hydrolysis, this will be converted to C double bond OOH, right? Okay, no. After doing hydrolysis, no. After doing hydrolysis, this will be converted to C double bond OOH. Then after that, you add reducing agent, this will be converted to aldehyde. So I think ethanol should be the correct answer here. Methane, note, acetaldehyde, yes, we can say this is acetaldehyde. So answer will be D is the correct answer. Wait a minute. Why so? Oh, yeah, because LiAlH4 is a very strong reducing agent. It's not a weak. If you have any weak reducing agent, then this will happen. You have a strong reducing agent. So strong reducing agent will further reduce it to CH2OH, that is ethyl alcohol will be formed. Okay, you have a strong reducing agent, not a weak reducing agent. Okay, so that will be converted to, firstly this is converted to CH3COH, then with strong reducing agent, that is directly converted to alcohol, right? Okay, next question we have the boiling point of, beta, try to answer these questions. Okay, so very quickly I am summarizing all these questions for you because I know the time is very precious for all of you. The boiling point of 3 isomeric pentenes are this. Boiling point, we know that more the branching, less is the boiling point. That is inversely proportional, so that is correct. When branching increases, the molecule attains a shape of sphere. Yes. This results in smaller surface area for contact, due to which intermolecular forces between these are weak, thereby lowering the boiling point. This is also correct. And if you ask why, this is giving the explanation why branching is inversely proportional. So we can say that both the statement are correct here. Okay, both the statement are correct, and that is the correct explanation as well. Right? So answer will be A is the correct answer. Next question is fluorobenzene can be synthesized by the laboratory. Fluorobenzene. Fluorobenzene is what? This thing. Fluorobenzene is this thing that can be synthesized in the laboratory by which of the following? So if you see fluorobenzene that is synthesized, there are so many methods. By heating phenol with HF and KF, definitely not directly, it's not possible. From aniline by diazotization. Okay, if you have aniline and you do diazotization, you convert it into N2Cl, followed by heating disonium salt with HBF4, definitely you will get fluorobenzene. Can you tell me the name of this reaction? That is Bals-Schiemann reaction. Bals-Schiemann reaction. Let me see how many of you got it right. B. Very good. Sai, Sriram, Bunny, very good. Bals-Schiemann reaction. B is the correct answer. S we don't need to see. F2 gas, definitely direct is not possible. Bromobenzene with NAF, definitely it is also not possible. That is for NaI. You can form ido compound, right? Not fluoro, right? So answer will be B is the correct answer. Next question is identify A and B in the following reaction. So this reaction is given to you. They have asked you to identify A and B here. So A is what? A is, where is A? This is A and this is B. Now they are saying that you have CH3, CH, double bond, CH. After ozonolysis, you have 2X. Now this is, we know that ozonolysis means this bond will break. You will have double bond O here. That means it will be CH3. That means it will be CH3, C, double bond O and H. Two amount of this is formed. Now after that you add NaOH. That means you do this has alpha hydrogen, you do aldol condensation, then again you add ozonolysis. Okay, so in this case you have CH3, C double bond O, this is H, this is CH2H. Just a way of writing has changed, right? So these two molecules, this carbon will be attached to the carbonyl carbon. Here you will have CH3. C, this will be converted to OH, right? Then this you have hydrogen here. Then here you have the attachment of CH2. This is CH, right? After the elimination from alpha and beta position, you will have a double bond. Then you are doing ozonolysis here. That means again you have to break this pi bond and you have to attach double bond O on both sides. So it will be double bond O H CH3 plus this is CHO CH. Isn't it? This is what you will have. So let us see what they are saying, that this is CHO, CHO. So answer is CH3, CHO, CHO, CHO. B is the correct answer here. Right? Okay. Again, we have to do ozonolysis 2 times here. Right? So B will turn out to be the correct answer here. So answer will be B is the correct answer. Next question is, a halogen compound X on hydrolysis gave alcohol Y. So there is some halogen compound on hydrolysis, it will give you alcohol Y. The alcohol undergoes dehydration with 20% H3PO3. What is the value of X? See, if it is easily undergoing, if some alcohol is easily undergoing dehydration, that means they are talking about 3-degree alcohol, right? So if you talk about this is X, then it will give you this as the alcohol. 3-degree alcohol will be formed, right? Only in this case you will see 3-degree alcohol. That is why the chances of dehydration is maximum here. OH and then H, the chances of dehydration is maximum here. So it will be double bond CH2. So in all other cases, this is CH, but this will be 2-degree alcohol will be formed, 1 degree will be formed, 1 degree will be formed. So this is the only option, that is A is going to be the correct answer here, right? Okay, next, let us see. Next question is, C2 is rotated anti-clockwise 120 degrees about C2-C3 bond. The resulting conformer is. Now they are saying that it is rotated C1. See, they are saying C2-C3. This is basically beta, this is C2 and the backward is C3. So this is rotated how many times? 120 degree. So if 60 degree it will be here, again 60 degree it will be here. So that means the answer will be, you will have something like this, 1, 2, 3, H here, you will have CH3 here, right? And here you will have H, you will have H, and here you will have CH. Now, can you see the resulting is eclipsed? No. It is partially eclipsed? No. It is gauche? Yes. It is the gauche structure, right? You can't say, ma'am, this is staggered. Staggered has two types, gauche and anti. Out of that, when they are next to each other, that is gauche. When they are opposite to each other, that is anti. So here, this is C is the correct answer. That is gauche is the correct answer here, right? Okay, right? Eclipse is overlapped, right? When you have, let's say, this kind of situation, right, where it is overlapped, right? Staggered is when they have some angle between them, right? That is staggered. Okay. Next question is, consider the following reactions. So these reactions are given to you. What you have to consider here. Okay, so this is they are asking you what is the reagent that you can have here. So you can see that here negative part is attached to more number. That means the anti-Markovnikov rule is attached. Break the pi bond, negative part OH is attached to less number of hydrogen. That means Markovnikov addition is here, right? You can't say that, ma'am, here acidic hydrolysis is also possible, because this acidic hydrolysis you do, methyl migration will occur and you will have this kind of answer. You will have this kind of answer in acidic hydrolysis. This is CH3, this is CH3, then you will have positive, then OH will get attached here. For acidic hydrolysis, so this is already eliminated, right? Anti-Markovnikov means hydroboration oxidation, right? And Markovnikov means oxymercuration, demercuration. So answer is B is the correct answer here. Okay, B is the correct answer here, right? Okay, are you able to understand? Yes, students, let me see B. Yes, ma'am. Okay, very good. Which of the following alcohol is dehydrated most readily with concentrated H2SO4? So which of the following is dehydrated most readily with concentrated H2SO4? If you see this here, dehydration we have to see. See, for dehydration, you will have the formation of carbocation, right? So we have to see the stable carbocation. If you see this here, carbocation formed will be CH. This is CH3. This is the positive here. Here it will be OCH3, CH, CH3, right? Here it is going to be CH, CH3, and here it is going to be, and here it is going to be, and here it is going to be CH, CH3, and here it is Cl. So whenever you have a carbocation, which is the most stable, you just have to have stable carbocation is what? Here you are taking, if you say this is positive, see this will be like this kind of situation will be there. Okay? So it will be something like this, right? double bond, and double bond. It will donate the electrons, right? And here also we are donating the electrons, right? In this case, what will happen? In this case, what will happen? Here also it is donating the electrons. Here also it is donating the electrons, right? Okay. That is simply donating the electrons with benzene ring. See, when you have a positive charge, more the donation, more will be the stability. So both are making it stable. Here CH3 is common in all of them. So there is no point of discussing CH3, right? We have to discuss this. So it is withdrawing the electron, minus M and minus I effect it is showing, right? It is showing it is showing plus M and minus I effect and minus I effect, right? So if you see here, you have no effect. Here you are donating the electron, so maximum stability will be for B, right? Maximum stability will be for B. If you need to write the order here, then what you will have B, minimum will be for C. Why? Because it is least stable. You are taking out the electron. You are already poor. Someone is taking out electron from you. Here you are giving the electron with plus M, but minus M, you are also taking out the electron. So overall you are deactivating the ring, right? So after this you will have D, and then the last one which has no effect, you are not taking the electron. So here it will be BADC, right? BADC, answer will be B has the maximum, and the order if they ask you, that is the order. Okay, remember that in halogens, always mesomeric effect is more dominating, but only in case of halogens, inductive effect is more dominating. That is why this is a case of deactivation of the ring, right? Okay. So that means that is going to be the correct answer. This is going to be the correct answer, right? Okay. Yes. Now, next one is the major product obtained in the following reaction. The major product obtained in the following reaction, this is NaOH. See here, whenever you have NaOH, just think about Aldol or Canizar, right? Because we know that here you have alpha hydrogens, alpha carbon, you have alpha hydrogen, that means this will be aldol condensation. And from the option, it is clear that we are going to have cyclic ring here, that is intra-aldol condensation will be there, right? For that, see, two things are possible. Either this alpha will get connected to this carbonyl, because always alpha carbon is connected to the carbonyl. Only here you have alpha, so I'll focus here, right? Either this alpha will get connected to the carbonyl. Here you have 1, 2, 3, 4, 5 membered ring. Here you have 1, 2, 3, 4, 5, 6, 7 membered ring. Now always remember 5 membered ring is more stable as compared to 7 membered ring. That is why this possibility is eliminated. Only this possibility you have. So you will have 5 membered ring, in which if I draw this 1, 2, 3, 4, 5, in the, let's say, 5th position you have CHO. Wait a minute. Let's say this is first position. First position you have C double bond O, and this is CH3, right? Then you have 2, 3, 1, 2, 3. 4 position you have CH3. Then here you have, in the 5th position you have CHO. That is really double bond O. No, that will be not double bond O, because this is converted to OH, no? So this will be C double bond O, this is H, right? This will be converted to OH, right? So that means here this will be OH, right? Can I see any option here? This will be converted to OH, right? Now, we know that from alpha and beta position, this is alpha and this is beta, you will take out water, so it will form a double bond like this. So you need to find out a situation where double bond is connected to, let's say this is 1, next to it you have a double bond, then next to it you have methyl, that means D is same as this, right? So D will be the correct answer, right? So D will be the correct answer here. You need to see that there will be less, the more stable ring will be formed, that is 5-membered ring is more stable as compared to, see, if in one case, let's say you have 6-membered, in one case you have 5-membered, then 6-membered will be preferred, right? So that it's not like always 5-membered is preferred. You need to see that which ring is more stable, only that ring will be preferred here. Wait a minute, wait a minute. Why? Have we done some mistake? This is 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. On the fifth position, you have OH. Fourth position, you have CH3. First position is this, where you have COCH3. Right? So from alpha and beta position, you will take out water, right? And that will give you the double bond here. Then according to that, this should be the correct answer, isn't it? Or C? Let me see why. Oops. Okay. I got it. What mistake I did? So very minor mistake here. When we have formed, because we are taking it from alpha and beta, na? So this is OH, right? This is alpha, this is beta, right? By mistake, I thought this is C double bond O, right? This is alpha, this is beta. If from here you are taking OH, then from here you will take out H. Then the answer would be this is double bond, this will be double bond here. This will be C double bond O, CH3. Then you will have one CH3, right? Then answer is going to be C is the correct answer here. Okay, right? Alpha and beta just I took, right? Okay, yes. Okay, so that was the mistake that I did, my bad, right? Okay, so that is alpha and this is beta. From alpha and beta we will form the unsaturated, so that was alpha, right? So that's why C is the correct answer. Now next question is butane 2-one can be converted to propanoic acid by which of the following? Butane 2-one is what? 1, 2, 3, 4. On the second position you have double bond O, right? Now they are saying you have to convert it into which of the following? Propanoic acid. That means you have to convert it into COH. This is CH2. This is CH3. This is where you have to convert it into. Right? Now what we will see that when you use spelling solution, this is not possible because it is ketone. NaOH and this is NaOH. This is tolerance is also not possible because this is ketone. This, because it is a methyl ketone, then that means haloform or iodoform reaction, this reagent is of no use, right? So that is NaOH plus I2, that will give you NaOI, right? That is important, right? Now this is going to convert this into one carbon less salt of carboxylic acid plus CHI3, right? That is yellow precipitate, right? So iodoform reaction, by iodoform reaction you can convert this. So answer will be C is the correct answer here, right? Next question is C6H5COCl with NH3 you have X, then P2O5. Now tell me in the chat box what is this P2O5? What is the use of P2O5? Let me know in the chat box. Right? Then it gives Y. Then you are reducing it. Right. So NH3 means you will convert this into CONH3. That will be converted to amide. After that, what is the use of P2O5? Anybody in the chat box? Anybody in the chat box? So if you see, this is converted to CONH2. This is P2O5, H3PO4, H2SO4. All these are very good dehydrating agents. Okay. So here it will dehydrate. That means H2 and O from here. So it will be C triple bond N will be formed, right? Then you do reduction, right, with nickel and H2. Then this C triple bond N is converted to CH2NH2, right? So that thing is formed here. So that is going to be your final answer here, right? That is going to be the final answer here, right? Okay. Next sequence is identify Z in the following sequence. So you have Z, you have to identify Z in the following sequence. So again, first is KCN. So what will happen? CH3, CH2. This is CN. Then you do hydrolysis. This will be converted to COOH. After that, again you do the hydrolysis, right? Again, hydrolysis is what? This will be converted to CH3, CH2, right? Once it is converted to amide, then it is converted to COH with double hydrolysis, so it will be D, right? Because first thing it is C triple bond N is converted to, see, first thing is this will be converted to CONH2. Then it is converted to COOH, so answer will be D is the correct answer here, right? Okay. Next, let us see inorganic chemistry. Let us start doing the questions of inorganic chemistry here. KCN means KCN. Yes. Okay. So, inorganic chemistry, let us start with the questions of inorganic chemistry. So, here it is. The first question is, or oxygen and sulfur both are members of same group in the periodic table, but H2 is liquid and H2S is gas. Reason. Why? Because molecular weight of water is more, electronegativity, H2 is weak. Water molecules are having weak hydrogen bonds between them. That is the reason, because of strong force of attraction, hydrogen bonds make it strong. That is the reason, right? They will have hydrogen bonding and the bonds will be stronger. That is why they exist in the liquid state, while this exists in the gaseous state. Okay? Yes? Thank you. Chalo. Now, next one, you have NaOH, SO2, A plus H2O, something A we have, then some B we have, which is giving what, which reacting with water and SO2 is giving you NaHSO2. NaHSO4, see, first thing is from that NaHSO4 is not possible, so this is eliminated, this is eliminated. See, with the logic also, if here you have NaHSO4, this answer will not be NaHSO4, right? So this is eliminated, this is eliminated, right? Right. So Na2SO3 is definitely right. Then what about this? Na2SO3 or Na2O? Anybody in the chat box? See, you just need to know the reactions. See, if you talk about this NaH plus SO2, you have Na2SO3. And if you have Na2SO3 with water and SO2, it will give you NaHSO3. Right? Okay. So that was your A. That was, this is what A. That was B. And A and B is what they have asked us. So you can easily answer that. A and B is going to be, A is the correct answer here. Okay. Right? This is reaction based question. Okay. Next is the decreasing oxidizing ability. Let us see the next question, everybody. Let us try to solve it. Right? Okay. Yes. Let us see this here. The decreasing oxidizing ability of halogens in aqueous solution down the group is evident from which of the following? Oxidizing ability of halogens in the aqueous down the group is evident from which of the following? See, when you go down the group, fluorine, chlorine, bromine, iodine, ability of halogens that decreases, oxidizing ability, yes. That is represented by a standard reduction electrode potential, right? So answer will be A, because we know that reduction potential is inversely proportional to reducing power, is directly proportional to oxidizing power, right? So that will all be interrelated with each other. So answer will be, because that is interrelated, that is why the answer will be standard electrode potential, whether it's reduction potential, it's oxidation potential, that will tell you the oxidizing and reducing power here. So answer will be A as the correct answer. Next is, next question is, Complete the following reaction. So see, this reaction is given to you. You have to complete the following reaction here. First is NH. Okay. First is when you have NH3 in excess. Then it is when you have Cl2 in excess. Right? Anybody in the chat box? See, when you have NH3 in excess, then NH4Cl is formed. Right? When you have Cl2 in excess, then NCl is formed. Okay. Acha, acha, theek hai. So that means these two are eliminated, right? So when you have NH3 in excess, then N2 will be eliminated side by side, and here HCl will be eliminated. So answer will be A is the correct answer here, right? Answer will be A is the correct answer. When NH3 is in excess, you have NH4Cl with N2. When Cl2 in is excess, you have NCl3 and HCl, right? So that's why A will come out to be the correct answer, right? Okay, let's see the next question here from inorganic chemistry only. Guys, this is, I believe that you will be easily able to do this, right? Okay, I believe that you will be easily able to do this. Yes, very good. Try to answer this yourself. Try to answer this yourself, students. Try to answer this yourself, right? I believe that you can easily do this. Okay, let's answer this, right? So here what we have, match column 1 with column 2. Okay, so I'm matching two columns. So one is XCF6. See, one thing is we know that xenon has 8 outermost electron, right? Noble gases. 6 will be involved in bond pair. So you will have 2 electron means 1 lone pair. 1 lone pair plus 6 bond pair. That means it is going to be distorted octahedral, isn't it? That means because it is 7, no. So it will be sp3d2 distorted octahedral. So 1 will be 1. So that means 1 will be 1 is here, that is present here and here. So these two are already eliminated. Second, you will have either 2 or 3, let us see. XCO3, we know that. Again, outermost electrons are 8. Oxygen is always double bondedly attached. So it will be double bond O, double bond O, double bond O. Total 1, 2, 3, 4, 6 electrons you have. That means again 1 lone pair, because 2 electrons will be left behind which are unshared. 1 lone pair you will have. So sigma bond is 3 plus 1 lone pair, it means 4. So answer will be xenon, 1 lone pair, 1, 2, 3, 4, 5, 6. That is pyramidal shape. Because in shape we exclude the lone pair, so that will be a pyramidal shape. So answer will be second is 3. Second is 3. Right? So this is again eliminated. So answer will be A is the correct answer. But still, okay, just give me a minute. Again, I'll solve this for XeO4. 8 outermost electron, 4 are occupied in formation, bond formation with fluorine. 2 are occupied in bond formation with oxygen. So it will be 2 electrons left, that is 1 lone pair. 1 lone pair plus 5 sigma bonds, 4 plus 5 sigma bonds, that is 6 means sp3d2, that is octahedral. But if you see this here, sp3d2 it will be, but it will be 1 lone pair, 1, 2, 3, 4, 1, 2, 3, 4, and 1 double bond O. That means it is going to be square pyramidal, that is 4. Okay. Last is XCO4, XCF4. So what we can do, don't worry, all the diagrams we have drawn on the next page. Don't worry why I'm erasing this. I'm just solving this for you, right? Xenon is 8 outermost because it is belonging to noble gas, right? That means 18 group, that means 8 outermost electrons. 4 is involved in the bond formation, that means 4 electrons, that means 2 lone pair. 2 lone pair plus 4 bond pair is 6. So again it is sp3d2, that is octahedral. But here you have 2 lone pairs, okay? So 2 lone pairs will be present here, 1, 2, 3, 4. 4 fluorine atoms you have, that is nothing but that is square planar, that is 2, right? Answer we have got before also, but just trying to tell you that how to solve the questions, okay? How to solve all the questions here, right? Okay, Next one on your screen, a theoretical question. Students, theoretical question on your screen, right? Okay. In context with the transition elements, in context transition, which of the following statement is incorrect? Guys, I'm waiting for your answers. Okay, I'm waiting for your answers. Right? I'm waiting for your answers. Right? That will be there in BITSAT. What do you think? Right? What kind of questions? These are the predictable questions, guys. Predictable topics. Okay? Right? Don't miss on to these topics. In context with transition elements, which of the following statement is incorrect? In addition to normal oxidation state, the zero oxidation state is also shown by these element in complexes. Okay. In the higher, that is true. That statement is true because transition element state also shows zero oxidation state sometimes. In higher oxidation state, transition metal atoms show acidic basic character. Okay, higher oxidation state, first 5 elements, all the 4s and 3d electrons are used for bonding. That is also correct. Once in D5 configuration is exceeded, the tendency to involve all the D3 electron in bonding decreases. That is also correct. See, this statement is incorrect. Higher oxidation state, it will be acidic. More the oxidation state, more is the acidity. So this is the incorrect statement. This we have seen so many times. Oxidation state is directly proportional to the acidity here. So B is the incorrect statement here. Right? Okay. Next, let us see next one. Amount of oxalic acid present in a solution can be determined by the titration with KMnO4. Solution. Okay, this is a theoretical question. They are saying that oxalic acid is present in a solution can be determined by titration with KMnO4 in the presence of H2SO4. The titration give unsatisfactory result when carried out in presence of HCl. So they are saying that we always add H2SO4, we don't add HCl here. What is the reason behind that? Gets oxidized by oxalic acid to chlorine, furnishes H positive ion in addition to this, reducing permanganate to Mn positive, oxidize oxalic acid to carbon dioxide and water. So what happens here? HCl itself will be converted to chlorine, right? And what will the titration of this with this in presence of HCl give unsaid, because KMnO4 can also oxidize HCl along with oxalic acid. That's why HCl will get converted to Cl2. That's why satisfactory result you don't have here. Otherwise, KMnO4 only was able to oxidize oxalic acid because there was nothing else. But now HCl is there in the solution. H2SO4 is not easily oxidized by KMnO4. That is why we use H2SO4, right? But this is oxidized, so answer will be, wait a minute, gets oxidized by oxalic acid to chlorine. Not by oxalic acid, this is oxidized by KMnO4. Right? Furnishes H positive to those from oxalic, reduces permanganate to Mn2 positive. That means KMnO4 from +7 it is converted to +2. That means KMnO4 itself is getting reduced. That is why it is acting as a very good oxidizing agent. So answer is C is the correct answer here. And it will convert HCl to Cl2. Okay, HCl to Cl2 it is going to convert. Right? Okay. Next question is, larger number of oxidation states are exhibited by actinoids than those by lanthanoids. The main reason is, see, why larger oxidation states are exhibited? 4f orbitals are diffused, lesser energy difference between 5f and 60. So because of less energy difference, the variable oxidation state are more in actinoids as compared to lanthanoids. So answer will be B is the correct answer, right? Okay, B is the correct answer. Next question is, which of the following statement is incorrect? They are talking about the bond length. Beta C, bond order is inversely proportional to bond length, right? So what you have to see is bond order. If you see O2 has how many electron? It has 8 into 2, 16 electrons. O2, 2 positive has how many electron? It has 14 electron, that means bond order is 3. See, corresponding to 4, bond order is 3. When you increase the number by 1, bond order will increase by 0.5. So 15 will have, it will decrease by 0.5. So 15 will have 2.5, 16 will have 2. Okay. So here we can see from O2 to O2 positive, bond order is increasing. So bond length will decrease, right? So that is the correct statement, right? O2 to positive has more bond order, so that's why bond length will be less. What about O2 positive and O2 negative? Okay, O2 positive is 15 electrons. That is going to be what? 15 means it will be, subtract 0.5, it will be 2.5 here. Beta 14 is 3. If you go down, just subtract 0.5. If you go up, just subtract 0.5, right? So if 14 is 3, 15, you go, like you add the electrons, it will be 2.5, right? So we know that again, O2 to negative, we have to compare it with, okay? O2 to negative. So this is 16, 17, 18. See, if 14 is 2.5, 14 is 3, then it will be 2.5, then 2, then it will be 1.5, then 1. 14, 15, 16, 17, 18. So it means for 18, you will have 1. For 18, you will have 1. O2 to negative has less bond order. So that means bond length will be more. But they are talking about bond order here. Bond order of O2 positive is greater. So this statement is the incorrect one. So this statement is the incorrect option here. So answer will be B is the correct answer here. Okay? Understood? Understood or not, students? What I am saying here is that 14 is 3. When you go down 16, 17, 18, right? This is up 13, 12, 11 and 10. Right? 14, 15, 16, 17, 18. 17, 18. So it will be 2.5 to 1.51. 2.5 to 1.51. Okay, this is what I am telling you. Okay, understood? Right? Okay, next is the correct order of boiling point. Boiling point in the following compounds is what? Boiling point, we need to have the force of attraction should be more. More is the boiling point. Okay, so if you see this here, force of attraction is maximum in water. So water will have maximum boiling point. After that, see, here you have 4 hydrogen bonds. Here you have 2 hydrogen bonds. See, maximum hydrogen bonds are in H2O. That is why it has the maximum hydrogen bonding. That is why maximum boiling point. But ma'am, fluorine is more electronegative because number of hydrogen bond are less. That is why this is preferred. But if you talk about HF and NH3, here HF is preferred. HF has more strong bond because fluorine is highly electronegative as compared to nitrogen. Here you have fluorine, this is oxygen, this is nitrogen. So as compared to fluorine, as compared to nitrogen, fluorine is highly electronegative. That is why this is more dominating in the electronegativity as compared to the number of bonds. So answer will be B is the correct answer for the order of boiling points. Right? Okay. Okay, students. Next question, let us see that. Specify coordination geometry around and hybridization of Na and B complex of NH3 and BF3. Wait a minute. Okay. I think this question I read it out before also, but it was the wrong question here. It should be like this, okay? It should be like this. Let me just correct it. It should be this. Only then some answer is possible. Otherwise, answer is not possible. So if you talk about NH3, we know that it is tetrahedral with sp3 hybridization. With BF3, it is planar with sp2 hybridization. So answer will be A is the correct answer here. Otherwise, you will see no, nothing is possible, right? They are talking about the geometry, right? Here they have given you the shape, right? So that's the reason, because they have specified geometry and hybridization. then this will be the correct answer, not C. Right? If they ask you the shape, then C would have been the correct answer. Okay, that depends upon what they're asking you. Right? Okay. Next is number, which of the following are isoelectronic and isostructural? Isoelectronic and isostructural. Okay, isoelectronic means number of electrons should be same. So if you talk about nitrogen has 7 electrons, 16 into 3, right? Plus 1, right? Carbon is again, this is 16 into 3 plus 2. So we can easily see they both are isoelectronic. Right? Let us see if they are isostructure, they are isostructural also. That means A will be the correct answer. Right? A will be the correct answer, guys. A will be the correct answer. So they are both isostructural as well, isoelectronic as well. So A is both have trigonal planar structure. So A is going to be the correct answer here. Right? Okay. Next is you have FeH2O5NOSO4 is paramagnetic in nature. See, paramagnetic, for that you should know that what is the unpaired electron. If you find the oxidation state, that will be X plus 0, minus 1, that will be plus 2, plus 2. Wait a minute. That will be, wait a minute. N is also, this will be minus 2, this will be plus 2 here. X will turn out to be plus 1 here, right? Yes. Because minus 2, this is not NO, then it will be minus 2 plus 2. Right? So if you see this here, X, this is plus 1 is equals to plus 2, right? Because this is a neutral, this is having plus 1. So it will be X is equals to plus 1, right? So iron will exist in plus 1 oxidation state here. So NO is positive, it is in plus 1 oxidation state, it is also very strong oxidizing, it is also very strong ligand. So iron, we know that it is 4s2 3d6. Iron positive is 4s1 3d6. When you are saying that you have a strong oxidizing, strong ligand here, that means it is going to pair them up. So you will have 3d6 here. So it is going to pair them up. So answer will be, this is 3d6. So it is going to be 1, 2, 3, 4, 5, 6, 7. Definitely it has one unpaired electron. So it is paramagnetic, right? Then Fe in this has 3 unpaired electron. Is it? Wait a minute. Fe in 1. If you are going to pair them up. Wait a minute. Let me see. Because here they're asking the unpaired electron like this, no? Then we should also know that 3d7, it is going to be how? It is going to be 3d7 like this. Okay, because all the electrons will be paired here. This is an interesting example, you know. Why? Because here, because of this NO, it will take out the electron from 4s and 3d also. Because, but here what you will see, because of 5 ligands of water, it is not exactly going to cause the pairing like this, what I did here. Rather, it will cause the pairing like this: 1, 2, 3, 4, 5, 6, 7. That is how it is going to be unpaired. Got it? NO will take the electron from 4s and it will pair them up and it will conclude to be 3d7. But after that, it will not cause the pairing like 1, 2, 3, 4, 5, 6, 7. No. It will rather keep the electrons. Firstly, it will be basically it will follow firstly Hund's rule. It's not that of a strong field ligand that it will not follow Hund's rule. Okay, so it is going to follow Hund's rule. Firstly, it is going to fill all the degenerate orbitals. Only then the next, only then doubly filled. That means only then the electron will be paired up. So that means this is also the correct statement. So statement 1 is true. Statement 2 is true. Both are true here, right? And 2 is going to have 3 unpaired electrons. That is why first is paramagnetic. So E is going to be the correct statement here, right? Okay, that is how the filling is going to be here. Got it? Because of NO, 4s electron is going to jump to 3D, but because of weak field ligand, that is 5 we have, it is not entirely going to cause the pairing, right? Okay. Next question is, the pair of compound having metals in their highest oxidation state. See, MnO2 is definitely +2, so it is not possible. If you see this here, it is X minus 8 is equals to -1. So Mn is in +7 oxidation state. It is X minus 4 minus 1 is equals to 0. So X is, wait a minute. This will be Cr2Cl2. It should be Cl2, right? Only then it will be 6, no? So X is equals to +6. This compound will be there. So it will be +6. So answer will be B is the correct answer here. Right? CrO2Cl2. This is the compound, not CrO2Cl. Okay, that is not the compound. Right? Next question is, the geometrical isomer of complex, this complex is given to you, are optically inactive. Geometrical isomer, they are saying both geometrical isomer of the complex possess axis of symmetry. See the geometrical isomer, if you see, that means cis and trans, if you see this here, this is going to be cis and this is going to be trans. And in both the cases, you can see a plane of symmetry passing here. Here also you can see, here also, wait a minute, if you see the plane of symmetry that is passing over there, right? If you see the plane of symmetry is passing over this NH3, or you can see the plane of symmetry is passing over this NH3, right? Wait a minute. If you have Cl here, this is 1, 2, plane of symmetry is passing over here, then it's not plane of symmetry. It is passing like this, then also it is not plane of symmetry. Wait a minute, let me just see that. Should I show you the 3D diagram of that? Because like this, it is not possible. Like this, it is not possible, right? Like this, it is possible. Like this, it is possible. If you see a plane of symmetry that is cutting this molecule into half, this molecule into half, right? And this molecule into half, and this molecule into half, right? Here you have NH3, that means plane of symmetry is possible in that kind of molecule. So basically what we are saying, a plane of symmetry that is passing like this. It is cutting the cake, keeping this into half, this into half, this into half, this into half. And these two are NH3, okay? That is how it is passing. So that means POS is present here. It is optically active, inactive, right? Here also POS is directly, you can see POS is present, right? So that's why you can say that both geometrical isomers possess axis of symmetry. That is true. Optically inactive, that is also true, because plane of symmetry is present, so it is optically inactive, right? So the statement 1 is true, 2 is also true. 2 is the correct explanation of A. That is A is the correct answer because of plane of symmetry, right? Wait a minute. True statement is not the correct explanation. That will not be true, right? Okay. So answer will be A only, right? Because it is the correct explanation. Okay. So we are explaining that both geometrical isomerism possess axis of symmetrical. That is why they are optically inactive. That is correct explanation. So answer will be E is the correct answer. Right? Okay. Okay. Next question is identify the incorrect statement regarding the complexes. So this complex is given to you. This is 3. So this is going to be +3. Right? Incorrect statement regarding this. See, first is it is going to be octahedral in shape. That is correct. Is it going to be paramagnetic? Let's see that. Chromium will exist in +3 oxidation state. Chromium is 4s1 3d5. Chromium 3 positive is 3d3. Right? So this is a strong field ligand, so it will cause the pairing here, right? So it will be 1, 2, 3. Even then it is paramagnetic. So this is paramagnetic. This is D2sp3. Definitely this is because D2 you have left here. You still have D2sp3, so that is also correct. Outer orbital complex, no. It will be inner orbital, that is D2sp3. The complex gives white precipitate with silver nitrate solution. Yes, because you have Cl outside. So with AgNO3, it is going to give you AgCl. So that is also correct. So answer will be incorrect statement is C. Right? C is the incorrect statement, that it is outer octahedral. Outer octahedral means sp3d2. Inner means d2sp3. So it is giving you inner octahedral, not outer octahedral. Right? Now let us see some questions of physical chemistry, students. Right? Okay. Let us see C is the correct answer. Let us see who can answer the questions of physical chemistry. Right? Shivas, Sriram, Sai. Let us see that. So if you see this here, first question is calculate the energy required for the process. So this energy is given to you. The ionization energy for H atom in the ground state is given to be this at per atom. So what they have given you, calculate the energy required for this process. So as you can see, ionization energy will be opposite of the energy of that orbit. Energy of that orbit you can calculate it from minus of 2.18 into 10 raised power minus 8, that is for hydrogen, multiplied by Z square. For helium, Z is equals to 2, so this will be 2 square, that is 4, and this will be the answer for energy of that electron. So when you have to take that electron, ionization energy will be minus of that thing, so that will be positive in this sign. So answer will be 8.78 into 10 raised power minus 18 is the correct answer. Okay. Remember that whenever they ask you ionization energy, you just have to calculate the energy of that electron. Negative of that will be the ionization enthalpy. Okay. Next is the sodium flame test. So now here they're talking about sodium flame test has characteristic yellow color due to emission of wavelength this. What is the mass equivalence of one photon of this wavelength? Photon is given, right? We know the formula of energy with photon. So directly we'll apply that. We know that lambda is equals to hc, or you can see that energy is equals to hc by lambda, right? Or you can just directly calculate this as lambda is equals to h by mc. De Broglie equation you have, no? P is nothing but momentum, right? That is mv, right? So this we know. Now, if you want to calculate the mass here, mass equivalence they are asking, that is h by v into lambda, right? This is what we have. Now, can you see h you already know, lambda is given to you, right? Emission of wavelength, what is the mass equivalence? The sodium flame test has color due to this, right? Velocity, because there they have given you that sodium wavelength characteristic yellow color due to emissions of wavelength of this, mass equivalence of one photon. So you can say that okay, it has the speed of light here, so it will be 3 into 10 raised power 8. That will be the speed of light, right? Okay, that is the value of lambda in meters, and this is the value of h. You solve this and you will get your answer here, right? Okay. Next is calculate the magnitude of spin angular momentum for an electron. Spin angular momentum, right, for an electron, see spin will be half only. Formula you should know that spin angular momentum formula is h by 2 pi under root s plus 1. You put the value of s is equals to half here. When you put the value of s half, this is what you will get here. This is what you will get. That will be H could see that depends on the option, what is given in the option. So according to the option, you can see if the option is given under root, this is given in H, so it will be under root H by 2 pi. 4 pi. If this is given to be under root, this will be h by 2 pi, that is h cut. This will be 2, so it will be under root 3 by 2. This is h cut. So that depends that what they have given you in the options. Okay, so in the options, whatever is given to you, according to that you will frame your answer. Okay, right? Now next is calculate the pH. Calculate the pH of the following half cell solutions. Also molarity of the acids. Two things are given to you. They have asked you the pH of the following cells and also the molarity of the acid. So if you see this here, right? Okay, if you see this here, firstly, you need to see the equation, right? This is platinum H2, this is anode and this is cathode. That means at anode you have H2, at cathode you have H positive, right? So you can directly write the equation as H2 and this is H positive. This is how the equation in simple terms will be, right? Because anode, you can write it on the left side, cathode, you write it on the right side because you have H positive and you have two H positive, so I have written two H positive here. Two electrons are getting lost here, so I have written two electrons here. Now the important part starts. If you see, we know that for standard hydrogen electrode, E naught value is 0. So this is going to be 0. This is overall Nernst equation. This you can put the value of reduction potential, oxidation potential, whatever is your choice, right? But see, if you're putting it here, if you're putting, let's say, one very important thing is, here if you're putting oxidation potential, here also you put oxidation potential. That is important. So here what they have given you, following cells and also the molarity. So here they have given you the E cell value here because if this is given for this reaction, in this reaction loss of electron is happening. That means this is oxidation potential is given to you, right? That means here oxidation potential is given to you, right? So should we point this 2 electrons, that is the N factor log of product by reactants. Product is H positive square by reactant is P of H2. Pressure of H2 is 1. If nothing is given, you will take it as 1. Even in the question, it will be given as 1 only. Right? Now, here you solve this, you will get the value of minus log. You will get the value of minus log of H positive. That is nothing but pH. So, basically, what you have to do, solve the value of, instead of solving the value of H positive, solve the value of as it is log and minus, so that you don't have to take the anti-log and log again and again. Okay, so directly you will see minus log of H positive, that is the pH value is given to be this, right? So this is what they have asked you here, the pH of the following half cells and also the molarity of the acid. See, acid is 2, you have 2 H positive, so this H positive concentration multiplied by 2 is going to be the molarity of the acids. Okay, right? Next question is, calculate the EMF of the cell in the following reaction. See guys, why I'm not getting into the calculation, because I don't want to waste your time. Calculation, even if I do it here, that is not going to benefit you in any case, right? So calculation you do yourself. I'm just giving you the concept, how to read the question, how to analyze what I have to do next. So calculate the EMF. E naught cell is given to you. This is a simple application of Nernst equation, right? So you have Nernst equation, E cell is equal to E naught cell minus 0.059 by N log product by reactant. In the reaction, you can see this is the product, this is the reactant, raised to power the stoichiometry. So Ag is raised to power 2. This concentration is given, this concentration is given. N factor, you can see 2 electrons are getting exchanged here. 2 electrons here, also 1 electron multiplied by 2. So N factor is going to be 2. Right? E naught value is given to you. Solving this, you can directly get the value of EMF for this cell. Okay? What is important? What is N factor? What is log of which thing? Product by reactant raised to power stoichiometry. Okay? That you should remember. Okay? That you should be very, very clear about. Next we have is reduction potential of 4 elements. PQRS is given to you. the decreasing order of reducing. See, reduction potential, reducing power. If you say reduction potential is inversely proportional to reducing power or reducing agent. Okay, reducing tendency, right? If someone has a very good, someone wants to get reduced, right? They would want to oxidize something else, right? That means they are very good oxidizing agent, but they will be very poor reducing agent. So here, just see opposite of reducing. See, they're asking you decreasing order, reducing power. That will be opposite. So maximum value of reduction potential, that is this, is going to have the minimum reducing power, that is this is P, this is Q, this is R. R is going to have minimum reducing power, right? P, which is having the minimum value of reduction potential, is going to have maximum value, then P, and you can see the answer is C as the correct answer. Okay, see the minimum, see the maximum. If no other option is there, that means tick that option only, right? Just know that what is the relation. If they ask me oxidizing power, that will be directly proportional. Okay. Now, next is for the following reaction, a curve. This is the curve. Concentration versus time is given below. Concentration versus time is given below. 2NH3 give rise to N2 plus 3H2. So this is given to you how to solve this. Okay. So if you see this, I calculate the rate of reaction in terminal of 5 to 5 seconds. So this is 5, this is 15. Time is given to be rate of reaction is going to be, because this is getting consumed, so that is time is given to be 10, and here how much concentration is changing. So that is at 15 it is 0.2, so you can take the minus because it is getting consumed here, right? So it will be minus 2.6, 0.4 divided by 10, it will be 0.04, right? That is going to be the rate of reaction, because see, now here understand one thing, that concentration of which thing is given. To calculate the rate of reaction in interval this, I think concentration of nothing is given to you. They have maybe not mentioned it here, right? If they have mentioned, then they should have mentioned here concentration of NH3. Then they should have mentioned here NH3, right? Because nothing was mentioned, that's why I was confused, right? So here they should have mentioned here that they are talking about concentration of NH3. We know that rate of reaction is equals to NH3 is getting consumed, so that will be 1 by, and one more thing, wait. If they don't even mention, then also you can solve it, because concentration is getting decreased, and decrease will be only of that reactant, and we have only one reactant. Okay, so that means the rate of reaction will be equals to minus, because it is disappearing. Always when you calculate the rate of reaction, you divide it by moles. If you simply calculate rate of appearance or disappearance, then you don't divide it with the stoichiometry, right? So we are calculating rate of reaction, so I'll divide it by 2 d of NH3 by dt. So that will be 1 by 2. Here also it will be 1 by 2, 1 by 2. So it will be 0.02. Right? So answer will be 0.02 is the correct answer here. Right? Okay, that was interesting one. Then I think, let us see how many questions we are left with. We are still left with so many questions, so I'll just speed it up, right? So calculate the order of the following reactions. See, this question is given to you how to calculate the order of such reactions. Okay, let us try to find this out. How to calculate the order of such reactions. So order of such reactions will be very simple. You have, firstly make NO constant, make NO constant. If NO is constant, we know that this is how much times? 4 times. This is 4 times, right? This is increased by how much time? 90 to 27, 36. 90 to 27, 36. Again, this is 4 times. That means rate with respect to NO, rate with respect to H2 is 1. With respect to it is 1. order of the reaction, because if it is getting 4 times, this is also getting 4 times. You can also solve it by R dash is equals to X raised to power N of R, right? X is the amount that concentration is increasing, that is 4 times. Then this total, we know that rate is coming out to be 4 of R. So that means you can say that 4 raised to power N is equals to 4. This will be equals to this. 4 raised to power N is equals to this. That means N is equals to 1. So order of reaction will be 1. Those who are not able to understand this thing, right? Otherwise, directly also you can see. Now I will make this as constant. Here this is multiplying 3 times. This is 3 to the 6, 3, 3. This is also 3 times. See, concentration and rate are getting same time. So here also you can write that rate is 3 times. Also, we know that X raised to power N. X means how much concentration is doubled? 3 times raised to power N. That means again N is equals to 1. Right? So that means with respect to NO also, it is 1 time. So order of reaction will be 2. Overall order of that reaction will be 1 plus 1, that is 2 is the correct answer here. Right? Okay. You don't need to solve it by this method. I don't like because that is very time consuming. Okay, so these methods we use for CBSE exams, right? For board exam, we don't use these methods for your competitive exams, right? You can ignore this method. Next is calculate the activation energy in this. Activation energy. See, if you compare this, we know that K is equals to A e raised to power minus EA by RT. We know that log of K is equals to log of A minus EA by RT, right? So this will be, if I just put it as ln of K is equals to ln of A minus EA by RT, multiplied by 2, then divide it. You multiply it by 2, then you divide the whole by 2, so it will be log of K log of A minus EA by 2.303 RT. Right? That means what is given to me in the question? Theta. We know that slope is equals to tan theta. That means here we can say tan theta in the question is given to be 3. So slope is given to be 3. And if you compare this, y is equals to, this is mx plus c. Here slope is, because x is 1 by t, so that is going to be 1 by t. So this is your slope. Slope is equals to minus EA by 2.303 R. Right? And slope is also given to be 3 in the question only. So now from here you need to solve the value of activation energy EA. You can easily solve that. Right? You can easily solve. This is, in fact, this is given to be minus of 3. So put minus, minus will cancel. EA is going to be 3 into 2.303 multiplied by R. That is going to be the correct answer here. Right? Okay. So just solve the value of EA here and you will 2.303 R into this. Put the value of R here and you will get your answer. Right? Now that depends that in what what they have given you in the question. Let's say they have given you in kilojoule, you will put it as 8.314. If they have given you in kilocalorie, you will put it in 2. Right? Ma'am, 0.0821 is when you have liter, volume, pressure in the formula. Then you use the value of R as 0.0821. Otherwise, for joules, you use 8.314. For calories, you use 2. Right? Because it is kilojoules, it will be divided by 1000. Kilocalories, it will be divided by 1000. For simply joules, don't divide it by 1000. For simply calories, don't divide it by 1000. Okay, some unit conversions I am telling you. Right? Next is an organic compound undergoes first order decomposition. The time taken for its decomposition to 1 by 8 and 1 by 10 of its initial concentration are this and this. Okay. See here, organic compound, something you have, time taken for the decomposition to 1 by 8 and this is this and this. Ratio, see, firstly, what you have to do, just put the formula of first order reaction. That is this thing, right? We know that T 1 by 8. That means initially it will be 1 and after time we will be left with 1 by 8. So you can take initial as 1, this will be 1 by 8, right? So you can have this is 1, this is 1 by 8. So that will be nothing but, see, down of 1, 1 by 8. So that will be nothing but ln of 8, right? This is what we have directly written here. Similarly, here for 1 by 10, this will be 1, this will be 1 by 10, it will cancel out and you will have ln of 10 here. So this equation also you know. Now when you divide it, k will cancel out and here natural log of 8 by natural log of 10, right? You can convert it here and this value when you will solve here, right? Because see, natural log of 10 is 1 only, right? 2.303 also here you will have 2.303, here also you will have, that will cancel out. Log base 10 of 10 is 1. So this value will be equals to 1. Log base 10 of 8, how you will solve? This will be 2 raised to power cube. So it will be 3 of 2. 3 will come to in the front. So it will be 3 log 2. Log 2 is 0.301. So you just put the value of, directly you can put 3. The actual value is 301.301. You can put it here. And this is the answer that you will get. Now they are saying you have to multiply it by 10. So you multiply that by 10, you will get 9 as the answer, 10, and this will cancel out, 9 will be the correct answer. Sometimes we, like in the hurry, what we see is T of 1 by 8 divided by T of 1 by 10. But they have asked you to multiply it by 10. So you have to multiply it by 10. Right? Okay. Next is the equilibrium constant Kc for the reaction at temperature is given to be this. The value of Kc for the reaction they are asking you. Equilibrium constant and temperature T is given to you. There, the value of Kc for the reaction, wait a minute. The equilibrium constant Kc for the reaction at temperature T is this. Okay. So this reaction we have to find, right? Firstly, we can see here you have 2 NO, here you have NO. So that means this will be multiplied by half. That means if here you have Kc, then this will be under root of Kc, right? Because whatever you are dividing it with, that will be in the power, right? So we are multiplying it with 1 by 2, so that will be in the power as 1 by 2, that is under root Kc. Now we are reversing it, so it is going to convert into 1 by under root of Kc. Right? So answer will be 1 by under root of Kc. The value of Kc for this reaction, that is Kc dash, 1 by under root of Kc, that is going to be 1 by under root of 4 into 10 raised to power minus 4. You just solve this and you will get your answer here. Right? Okay. Is that clear? Is that clear, beta? How much more zoom you want me to do? Huh? I think that is enough. For the reaction, CO plus Cl2 give rise to COCl2. Kp Kc is equals to. See, Kp is equals to Kc RT delta Ng. Delta Ng, here it is 1, here it is 1, here it is 1. So it will be 1 minus 2 is minus 1. So it will be minus 1 here. So Kp by Kc is equals to 1 by RT. So answer is going to be 1 by RT. That is A is the correct answer here. You just need to know this formula. Calculate only the gaseous moles, the difference in the gaseous moles of product and the reactants, and you will have your answer. Right? Okay, students. Next question is, which of the following equilibrium Kc and Kp is not equal? Again, Kp and Kc will be equal if delta Ng is equals to 0. Kp and Kc is not equal if delta Ng is not equals to 0. So you can see that here. Can you see that here? Right? Can you see that here? It is 1, 1, 2 minus 2, it is 0. That means Kc, Kp is equal. Right? So here it is 1, 2, 1, 2, again 2 minus 2, 0. 2 minus 2, again it is 0. This is 2 and this is 1. This you will not take. You only take the gaseous moles. Okay, so it is 2 minus 1 is 1. That means Kp is not equals to Kc. Kp is equals to Kc. RT delta Lg is 1. That means Kp is not equals to Kc here. So answer will be D is the correct answer where it is not equal, right? So D is going to be the correct answer here, right? Okay, students. So D is going to be the correct answer here. I think now we have some of the last two questions we are at. Last two questions, students, see this. For the reaction, this reaction is 2 mole of A, 1 mole of B, 1 mole of C are placed in 10-liter vessel, allowed to reach equilibrium. If concentration of C is 0.2, then calculate the value of Kc. It's a simple thing. Same thing you will use here. See, A plus B give rise to 2C. Initially, they are saying 2 moles of A, 1 mole of B, and 1 mole of C you have, right? At equilibrium, you will have 2 minus, this is minus alpha you will do, or you can say X, okay? You can also do X, right? So this is 1 minus X. What amount will be formed? 1 plus 2X will be formed. Now they have given you one hint here that if final concentration of C is 0.2, that means one final concentration is given to be 0.2. These are the number of moles. Number of moles, wait a minute, molarity is equals to number of moles by volume. So concentration you have to do. So for that you have to divide it with the moles, with the volume. Volume in liters, okay? Molarity is equals to number of moles divided by volume in liters. So you have to divide it with 10. Okay, so everything is divided by 10. Now, they have given you one hint here. The hint is given to be that final concentration of C is 0.2. That means 1 plus 2x by 10 is equals to 0.2. So you can just solve it. 1 plus 2x is equals to 2. 2x is equals to 2 minus 1. So x is equals to 1 by 2. Right? X will be 1 by 2. I think I have solved it right. 2, this is 1. So 2x is equals to 1 by 2. Right? So 2, that means x is equals to 1 by 2. Right? So x is equals to 1 by 2. You just need to put the value here. This is 2 minus 1 by 2 by 10. Right? 1 minus 1 by 2 by 10. This is 1 plus 2, 1 by 2 by 10. This is the value of A, B and C. Then you put the value of Kc here. Kc is equals to concentration of C square. This is A and this is B. You have the concentrations. You put this, you can solve this easily. Put the values here, you will get your answer. Okay? Put these values here. See, the simple funda is whenever they ask you Kc, calculate concentration with using this formula. Molarity is equals to number of moles by volume in liters. If they ask you pressure, Kp, in that case, pressure is equals to mole fraction multiplied by total pressure. These are the two things that should be in your head while solving these kind of questions. Okay, right? This is what we have done. X is equals to 1 by 2. You put the value, put it into the value of Kc, you will get your answer. Right? Now, last question of today. Right? Last question. Assuming that water vapor is an ideal gas, the internal energy change delta U when 1 mole of water is vaporized at 1 bar pressure and 100 degrees Celsius. Molar enthalpy of vaporization of water at 1 bar, that is given to you. Okay. Okay, R is given to you. Assuming that water, internal energy change is given to you, then what they are asking you? Wait a minute. Where is what? Assuming that water is ideal gas, so internal change is given to you. Okay. When 1 mole of water is vaporized at 1 bar, molar enthalpy of vaporization of water at 1 bar will be, okay. Molar enthalpy means they are asking you delta H. Delta H equals delta U plus delta NGRT. R is given to E is given. Delta NG they have already given you, right? So what else you are left with, right? So delta U is given, just calculate the value of delta H. So directly you just need to put it in the formula, right? Wait a minute. The internal energy change when 1 mole is vaporized at acha. The internal energy change when 1 mole of water is vaporized at this will be. Oh my god, kahan they have internal energy and this they have will be. Molar enthalpy of vaporization of water at this and this. Very nice, sir. They have just given less a grammatical way they have asked you, right? So molar enthalpy of vaporization of water, right? This they have given you when internal energy is what they are asking you. Internal energy change when this will be. That means delta U they are asking you, that is delta H minus delta NGRT. So we know that delta Ng is given to be 1 mole, right? So that is already given 1. R, whenever you're talking about energies, will be 8.314. Temperature is given to you, that is 100 degree. Delta H is also given to you. You can see this here. Delta H is also given to you. That is given to be 41 kilojoule per mole. That means 41,000 it will be, right? In joules, it will be 41,000. You just solve it and you will get your answer for delta U. Right? That's a very interesting thing that they have asked you. Internal energy will be. Okay, internal energy is here and will be is here, right? So that is why English kind of question, right? Okay, so students, we have done the last question as well, right? So for all of you, as you can know, even today we had a very interesting thing. First is for BITSAT, all the students, you still have time. So your BITSAT test series, you can see 10 mock tests here. That is at 649 rupees only, right? Yes, that is 649. You will get 10 mock tests here, and now you have the time to solve those 10 mock tests in between these days. So I would highly request you to click on this and solve these test series, which will be very helpful for you, because we can't come daily here and solve the question, and moreover you need to solve the question yourself as well, right? If ma'am is able to solve the question, that is going to help you in the exam, that okay, I have done this question, but the practice will make you perfect in the exam to manage the time and everything. For that you need to have this test series here. And students, if you see this here, if you're preparing for any other exam also, you can see the test series over here. List of test series all are available at 649, different exams. Extra mile test series is available at 1299. That is also available to you. Totally your choice that what is the exam you are preparing for. According to that, be fully prepared for the exam. There is no like enjoy or joy in that, okay, I am preparing for this exam. In your head you are preparing, but in reality you are not preparing, right? I think in that way you are fooling yourself. For proper preparation, you need to give mock test, only then you will be mentally prepared to be in the exam, right? And for all the students who are here, right, who, wait a minute, let me just click on this thing here. So students, if you're looking for the wait a minute, what we are getting into, right? Okay. So if you see this here, we ignite, ready to light it up. So what exactly you have here, right? So guys, this is basically your 2026 courses, right? What we have for you. So every detail is given to you in this particular video, right? You can go and check that out. That will be very helpful for you, right? All the details we have mentioned here, I'm not going to repeat the details here, because you can, that is just how much time video, that is just 19-minute video, and that will really help you if you are serious for 2026 preparation, right? Okay students, so that's it for today. Now I'll see you all in the next class. Till then, bye bye, take care, see you all in the next class. Bye bye.